Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology, Hyderabad. I welcome you all with another lecture on stream processing and analytics. So, up to last video, we have completed Unit 1. Now we are going to start Unit 2. Okay. Before going into the topic, we'll discuss the overview of today's presentation. I have divided my presentation into three parts. As a first part, I have divided into streaming architecture. As a second part, we are going to discuss the parts of a data platform, and finally, we are going to discuss architectural models. So here, what is streaming architecture? We'll look into the first topic now. The implementation of distributed data analytics systems has to deal with a pool of computational resources like cluster of machines or reserved clouds. Okay, here streaming architecture works with the distributed data system. Okay, here a multiple number of cluster machines. Here we can say this is one root node. Connecting with this root node, there are multiple cluster machines are working. Okay, all these parallelly works to get the proper data analysis. Okay, here this main root node will handle all the tasks of all the slave nodes. We can call these nodes as the slave nodes and this node as a root node. Okay, so this is nothing but the working of cluster of machines. Okay, we can call it as a cluster architecture. Cluster is nothing but it is a combination of multiple machines to achieve any task. Next, when the needs of two organizations differ, okay, suppose if we consider two organizations, both are requesting for the resources, it becomes important to give each a fair and secure access to the resources. Okay, distributing resources among these two, organization 1 and organization 2, has to be fair, right? So here, to distribute resources fairly for the cluster while making sure the computing resources are best utilized over time. So here, this kind of parallel processing will help both the organizations to achieve their goals by distributing resources in a fair manner. Okay, so now let's move on to the next slide. Okay, here data platform. So here architecture of a streaming data platform. Here we can say that the data platform and the position of a processing engine relative to the other components. Here architecture of a streaming data platform has a multiple number of steps, which include these a total of 7 steps. Okay, these platforms are working position of processing engines. With respect to each and every position, those processing engines work parallelly. We can see a data platform as a composition of standard components. Here we can say it is a composition of standard multiple components. Here all the components are working parallelly to achieve goals. Okay, going from the bare metal level at the bottom of the schema to the actual data processing demanded by a business requirement, you could find the following. Here we can say that we can discuss from the bare bottom level. Here why? Because here as a bare level it has a hardware. Okay, so if we can say there are multiple stages of data platform, we'll discuss one by one. The first level is the hardware level, next the persistent level, and after that the resource manager, next the execution engine, after that the data ingestion component, and before that a processed data link, and finally we have a visualization layer. So if you can observe in this diagram, there are all the levels involved from the bottom. Here you can see the hardware level, which is our first thing here, and the storage, that is nothing but the persistent level, and resource manager here is a yarn, it is a third step, and the execution engine is nothing but the Spark component here, and the data ingestion component is nothing but the Kafka, and processed data link layer is a here the data analysis and modeling, and visualization is nothing but it is a last step we can discuss. Okay, now let's move on to each and every step detail. The first layer is the first level is the hardware level, we can call on premises hardware installation. Okay, this level deals with the hardware installations with respect to the processing. Okay, and data centers or visualized or Okay, now we'll discuss each level one by one. The first level is the hardware level. On-premises hardware installation. Okay, this level deals with the on-premises, on the place hardware installations and data centers or virtualized resources, which means that a system-related resources with a bare operating system installed. With a base operating system installed. Okay, here it has all the installation part. This level deals with the installation with requires which are required for the data processing. We can say those are installations of any hardware or data centers connection or any virtualized resources. Okay, now let's move on to the next level, the persistent level. On top of that baseline infrastructure, okay, that is nothing but the hardware level. The persistent level, we have a persistent level. Okay, as a second part we have a persistent level to store the results of a computation as well as input. Here the persistent level will store the input as well as the results of the computation. It combines both results of computation as well as input. Okay, the persistent level deals with the computation with input. Okay, at this level we use the Hadoop distributed file system. Okay, this is a one type of virtualized database. We can say HDFS. It also works with the distributed file managing process. Okay, on the cloud this persistent level is provided by services such as Amazon simple storage services, Amazon S3. We can shortly call it as Amazon S3 or Google Cloud Storages. As we know, as a part of storages, we can have a physical, virtual storages. If we can call it as a physical, we can say it as a HDFS. Okay, this is a distributed file management, and virtually we can store the data in a Amazon S3 cloud storages. We can call these things as a cloud storages. So after computation we can store all these a result by using the persistent level. Next, as a third part, we are going to discuss the resource manager. So, with respect to the data analysis, after persistent level, most cluster architectures offer a resource managers. Okay, resource managers are also works with a combination to cluster architecture to submit jobs to be executed on the cluster. Okay, multiple machines are working with a in a combination of resource allocation. Okay, for example, Yarn, Mesos and Kubernetes are the examples for these resource managers. These cluster machines have the multiple resources which can distributed among multiple sources. The next step is the execution engine. At an even higher level there is the execution engine. Okay, this is execution engine is at a higher level. Okay, execution engine we have at a higher level which does the actual computation. Okay, actual computation has performed by this execution engine. Execution engine will perform actual computation. Actual computation of all the processes will performed by the execution engine. It holds the interface with the programmer's input. It holds the programmer's input to do the computations, describes the data manipulation. Also it has a data manipulation. It is a combination of input programmer input as well as the data manipulation steps. Okay, execution engine is a main source that computes the data. Apache Spark, Apache Flink or MapReduce would be examples of this. So here the execution engines, let us take an example. Apache Spark is one kind, Apache Flink and MapReduce is another kind of execution engine. And next we'll move on to the data ingestion component. Okay, what it is, we'll look into it. Besides the execution engine, you could find a data ingestion server that could be plugged directly into the engine. Okay, here this has the link between, there is a link between data ingestion component as well as with the execution engine. Why? Because the data comes directly to the execution engine by this layer or by this level. The messaging systems or processing engines such as Apache Kafka is placed at this level. Okay, if you can observe in the previous diagram here, this is the Kafka, which is the data ingestion component. Okay, data ingestion component. This Kafka source will directly move to the Spark. It is nothing but the execution engine for computation. Okay. Now here, next we'll move on to the processed data sync. Okay, on the output side of an execution engine. Okay, here if we can take Spark as an execution engine, it has an input and output, right? It has connected with both the components. This is input and this is output, right? So here in the input part, we have just now discussed about data congestion component, which is nothing but the Kafka, right? Here if we can talk about, output side, here it has a, it has a processed data sync, okay. Now we will frequently find a higher level data sync, which might be either another analytical system. If the execution engine perform ETL job, ETL is nothing but extract, transform or load, or a NoSQL databases or some other services. Okay, as an output side, the data which is computed and which got the output will store on the ETL jobs or on some NoSQL data storages or any other services. Okay, now let's move on to the last part, that is nothing but the visualization layer, which plays a key role to understand the data. The results of data processing are often given into visualization for viewing the results. Okay, after getting the output or results, we have to analyze it through visualization. Then only we can easily understand the data by using the graphs. The visualization has changed from the old static report towards more real-time visual interfaces using some web-based technologies like web pages designed with HTMLs. Okay, so visualization also evolved through the time. Okay, so in olden days we used visualization for visualization old static reports, but nowadays with the increase in a digital era, those real time analysis through visualization has also updated with some HTML web based technology. Okay, web based technology. Now with this, all the 7 layers are works to achieve any goal of the data processing. Now let's move on to the third part, architectural model. Okay, what is an architectural model? Means we have two types of architectural models, which has a combination of lambda architecture and kappa architecture. What are these architectures models? We'll discuss. Two concepts of streaming architectures are, the first one is lambda architecture, the second one is kappa architecture. Lambda architecture, if we discuss about lambda architecture, which suggests making a copy of streaming application with a batch application running in parallel to compare results. Here in lambda architecture, the input data is ingested into one stream application, and another one is for batch processing. As a result, after processing, in combination of these two, batch and stream processing, will get a proper output. Okay, proper output. So here we can say lambda architecture is a combination of both batch as well as stream application model. Now what is kappa architecture? This is totally opposite to lambda architecture, which says that if two versions of an application needs to be compared, both should be streaming applications only. Here, while dealing with any data, applications has to be in streaming applications only. It does not allow batch processing. Okay, so it is a, we can say that kappa architecture is a combination of both. Streaming to streaming architectures. Okay, here now we'll have a quick overview of today's presentation. As a part of unit 2, we have discussed about streaming architecture and the parts of data platform and the architectural models. Thank you.